Statics Chapter 3, Lecture Problem Number 2. A crate of a mass of 80 kilograms is held in a position shown. Determine the moment produced by the weight W of the crate about E. Okay. So immediately we are given mass, and we have to convert that to weight. So we have to multiply this by 9.8 meters per second, which gives us 784 newtons. Now, determine the moment produced by the weight about E. So this is our point E here. And we've got this distance. Is there any way I can change the color? There is, color wheel. I'll do red, just like the diagram shows. Yes. We have this distance here, from E to the center of the weight, which I believe that's where the weight would be determined, is center mass. And what this would be here is 8.5 we have a 6, so it would be 8.5 minus 6. Or 0.85. 0.85 minus 0.6, which equals 0.25. So we know that the moment is equal to R F sine theta. But in this case, the moment about E is equal to R times W. It's going to be 0.25 times 784, which equals 196. So that's our answer for A. And then it asks us, what's the smallest force applied at B that creates a moment of equal magnitude and opposite sense about E? So we are judging this about this point B to this point E. So we need to find this R, which is going to be the height of 0.5 here and the length of 0.8 here. So R equals, so this is A, and this is part B. R equals square root of 0.5 squared plus 0.85 squared, which is 0.986. Okay, now that we have this, remember that the moment for, I'm going to call this B, is equal to R F sine theta. Okay, RF sine theta, we want to know the smallest force applied. And theta for the smallest force applied is going to be 90 degrees. Theta is max when force is min. So now that we know this, our MB is going to be F sine theta is 1. So then this means that MB equals R times F. So now that it is, and I guess the force sine theta here, since the weight is going directly down, is also 90 degrees. So that's why it just becomes R times W. So here we just have R times F again. And we want to find this force that creates a moment of equal magnitude, opposite sense about E. Now we know the sense about E is right here. So we do 196 equals 0.986. And then this is the force we're looking for. So F equals 196 over 0.986, which becomes 198.8. And that is how you solve this problem.